Hello YouTube, how are you? Today I'm back with the third video in the series Mastercam 2D high-speed tutorial, and in the last two video we will talk about 2D high-speed dynamic view with the from outside and from inside option, and we take a look at what we done in the last two video. Okay, and we turn the verify option here. Okay, and see what we do. Next, in the first video, I will talk about. I just talk about dynamic mirror with the out from outside option. So you can see the tool and engage the material from the outside. And this is the outside option. You can see the tool and engage the material from the outside. And next, in the second video, I will talk about the Mastercam dynamic mirror with the stay inside option for close pocket. You can see we have the tool engaging from inside of the pocket with the Latin motion. You can use the helix Latin motion or ramping entry option. It's depend on you. Okay, you can see here we got some pocket mill. Alright, and this what we done in the last two video. We got the cut from the outside, we got the cut from inside, but we can take a look on this. We turn on the workpiece. You can see we have just forgot the material outside the part. We will remove it later, but take a look on the pocket here. You can see we have a little bit of material left on the corner. You can see here this corner, this corner, this corner, this, because we used the 0.5-inch tool for the roughing operation, so the tool cannot cut the material in small corner like this. You can see here, and for small corner like this area, the tool cannot move into to remove the material. So we need another operation to remove the material from this corner. And that's when we use the dynamic rest Toolpath. Okay, I will show you how to use the dynamic rest mill to machine to cut the material from this corner like this. The dynamic rest mill 2D dynamic rest mill used when you have to remove the remaining material left from the reverse operation, material left uh, from another tool with a bigger diameter. So we can use a small tool with a smaller diameter to remove the trash material on the corner or on the area where the roughing tool cannot engage. So how we use the dynamic rest tool, where you can find it? Yes, you can find it here. Just go to the Toolpath 2D high speed, and again we select the dynamic mill. The dynamic mill will contain the dynamic rest by checking one option. So this window open again, and like the same operation, reverse operation, you need to select a machine region. Okay, and as you can see on the verify, we have remain material on 4 pocket here. So we need to select the 4 pocket here at the machine region. You can either select chain in wireframe mode, or you can either select in solid mode, no problem. As you can see here, I select in wireframe also in solid, no problem, but need to check. Oh, it's allowed to select one kind at a time. Okay, I can select solid here. Alright, here. Yes, if you want to select also wireframe and solid, you need to select one first, then apply, then you can select another one. Okay, you can see I select 4 area here for machining region, and because this close pocket, I will choose the stay inside option. And in this case, because you just want to move the rest material, uh, no more than that, so I will not select the border region, no air region, no containment region, and no entry chain. Okay, that's all for the chain option. And you can take a look on this. For rest milling, you need to select a smaller diameter tool. In this case, I have a smaller tool. Is the .25 flat mill, because in the previous operation we used the .5, and in rest uh, dynamic mill operation we use a smaller tool, and I select a one sorry 0.25 tool here. You select the speed, feed rate for the operation. And next, how to activate the rest milling. You can see here in the left, you can see that we have the rest material here. That's where you want to turn on the rest milling option. If you tick on here, Mastercam will recognize this operation is the rest milling operation. Okay, you can see we have some option here. In the rest material area, Mastercam will ask you how to compute remain stock. You can let Mastercam compute the stock from all previous operation on all Toolpath group, or just uh, uh, sorry, or just Toolpath group of the operation only, or entire machine group. You can see select on group here for select all of operation in all group Toolpath group, or you can select only one or the operation. In this exercise, I have the third operation is the operation who machine the pocket, so I will select the third operation. I will select each option for you to see. Okay, for the first time I will select one order operation, and will select the third operation here, because this is the operation which is machine the 4 pocket. Yeah, and you can take a look on this. In this view, adjustment to remain stock, Mastercam give 3 options. The first option is you remain stock at compute. You can see this picture. Mastercam will consider the left material is equal to what it calculated, and this will make no change to the Toolpath. If you select the second operation, adjust remain stock to ignore small cup, Mastercam will reduce the rest material, so the tool will engage la material. If you're not sure about this, you not understand clearly what I say, you can just click on this button and go to the field definition, and you check on this. Mastercam will make a clear explain on this. So this is our 3 options. Mastercam will explain you what these options mean. So if in the case if you want to the tool engage the small material as the beginning. You can select adjust remain stock to mill small cup. So you can input the adjust distance. I don't want the tool to engage much material at the first cut, so I can input this distance, for example, 0.05. Okay, that's all for the toolpath. You check the linking parameter to make sure you select the right depth for the operation. Okay, and pick a distance point. Okay, click OK. And wait a few seconds. Ooh, what happened here? Mastercam. Oh, you can see here there's some problem. Mastercam mute the entire pocket, not mute the rest material. I will check for the reason. I will check the test operation here. Okay, I find out the reason. We check the parameter of the third operation. In this third operation, you can see here because you leave 0.01 inch for wall and 0.01 inch for floor stock. So the Mastercam will know that the floor also have the material, and in this Toolpath you leave no material on stock, so Mastercam will machine the entire pocket to remove the material on the floor. See, because this different. You leave the 0.01 inch material on the floor, so in this tool operation you leave no material on the floor, so the Mastercam will entire toolpath. So to avoid it, you can input this, change it to 0.01, so the material will be the same as the rough operation, and will generate the operation again. Let's see if any different. Alright, we have some different here. You can see that Mastercam just machine the corner, and you can see Mastercam will machine the corner only. Yes, you can see that this is the 2D high-speed dynamic rest mill. You can see here, if we select the rest option, it will become the 2D dynamic rest mill. Or you can change this to 0 in the rough operation, and if you change this to 0 here, there will be no material left on stock, and Mastercam will just make the tool pad at the corner. Yeah, you can see no tool pad on the center area because there's no material left. Yes, it's very important. Please take a note on the stock to leave on X tool pad. So that's the first option for the rest material. We select the one other operation. You can also select all operation. You will have the same result. Mastercam will calculate the stock from all operation before, and it will machine the rest material. Yeah, you can see here we have the same result. Or you can define the rest material by input the roughing tool parameter, and you input the diameter of the roughing tool. In this case, I input 0.5 because I use the 0.5 inch uh, flat MU in the roughing operation, and this is the corner radius. So we check what's the corner radius mean. Corner radius, yes, it's the roughing tool corner radius, because due to flat MU, so I have no corner radius. And input. Okay, yeah, we got the same result here. With the roughing tool option, you do not allow to select this option. If you want the tool engage with a small material, you can input this value is larger than the real value. For example, for 6, the tool will engage less material. Okay, if I input the 1, for example, Mastercam will make more parts, and the tool will engage less material. Yes, you can see there will be more tool paths depend on the roughing tool diameter you input here. So that is our dynamic rest mill. Very simple, right? Oh, something wrong. Oh, sorry, point 5, not 5. How stupid I am. Okay, and here the rest Toolpath, dynamic rest Toolpath. Pum pum. And we still have one kind of dynamic Toolpath. I need to I need to let you know this. That's the dynamic contour Toolpath. Beside the dynamic mill, dynamic rest mill, we also have the dynamic contour. So, as I told you at the beginning of the tutorial series, the dynamic contour is due for uh, normally it's used for cut the outside contour of the part. But if there is some area that has much material like this in this area, the dynamic contour will generate more tool path, more dynamic tool path to remove the material before it engage to this area. I will make another normal contour, 2D contour, and dynamic contour to let you see the difference. Okay, first I will make a 2D, normal 2D contour. We will machine the outside contour of the part. Okay, select the chain, and I select tool, for example, 1.5 tool, computer, alright, and let in, let out. Okay, now I will run the back plot to see how the tool will run. You can see here the tool start from here and to this area. You can see the tool will go straight to the material. It's burial and it's not good for the tool. You can see here we have a lot of material here, and the tool may break if you select a normal 2D contour. The tool will engage this, and oh, you can see a lot of material need to be removed. We call it tool mirror. Tool, oh sorry, I don't know how to uh, say it in English, but the tool will engage a lot of material in this area, Another one, when we come to this area, yes, again it will cut a lot of material. I will do the uh, simulation for you to see. Okay, so this is our contour toolpath. The tool will, for the outside area here, there's no problem because the material is not much. But when the tool come to this position, you can see there's a lot of material here, and if you use the normal 2D contour, the tool will get a lot of material here. You can see that. Yes, it's cheap load. It's about cheap load. You can see when the tool move here, it can be broken. And again, no problem. There's thin material here, but when it comes to this area, the pocket here, the tool will get a lot of material with a full diameter cut. Yes, not good for a tool. Not good at all, right? And here, this, you can see a lot of material will be cut. This area, and this area. So, this how we need to select the dynamic contour. Alright, I will select the toolpath here, 2D high speed, and I will select dynamic contour here. Again, for the machine region, I will select different with the dynamic mill. For the dynamic contour, you just need to select the contour you want to machine. Okay, you select this, and you can see with the dynamic contour there will be no stay inside and from outside option, just machine region. That's our contour. Alright, I will select tool and input other parameter like the previous toolpath. You know, so yes, the same parameter with the other toolpath, the other dynamic toolpath. So you can see what is the difference. In the contour wall, we have some option. Uh, we have the radius of tool that set the stock, the mean toolpath radius that set the stock, and the stock thickness. Okay, I will leave it the 0, 0, and 0 here for you to see the difference. Okay, and that's all to see what we got here. Oh, again a tool and gaze into the pocket. You see, oh, you will say, oh, why? I don't see any dynamic move in this toolpath. Why? Yes, the tool will. Oh. So, what's happened here? That's happened because you have not defined the parameter here. With the dynamic contour, you need to define a radius of the roughing tool. If you even you don't have any roughing tool before, you just need to input a very large value here, for example 5 or 10, something like this. You will input the value with the tool. With that diameter tool cannot go into these pockets, so the dynamic contour will take care of this. So we will input, for example 5 inches. Imagine that we have a 5-inch diameter tool milling this contour, so what material it will leave. Yeah, so I will put here, and I can leave the mean toolpath radius of the roughing tool here equal to 0, and stock thickness. Okay, I left 0 and to see what happened. You begin. You can see some dynamic move here, but why cannot engage into this area? Because the tool is too big, and mean toolpath radius parameter here is too large. I mean, put it here. You will see. Yes, that's good, right? Now you can see the difference. The tool will first cut the material outside the part, and after that it will turn back and cut the material from the pocket. Yes, here, here, and here. So I can use the smaller tool, for example, the PART 25 flat end mill. You can see this, for the tool, the cut will be smoother because the diameter tool is small. Okay, it will cut the material outside first, and then it will make the dynamic motion here, here, and here. You can see that's the difference between the normal 2D contour and dynamic contour. Yes, that we do very far. Okay, you can see here. I will review the speed. You can see it will cut the outside material first. Oh, tool will, you can see. I will speed it up a little bit so you can see the tool not engage to this pocket at the first cut. After it's milled the outside material, the tool will turn back and begin to cut into this pocket. That's how the dynamic contour works. So the tool will engage the material very gentle. Yes, very smooth cut. You can see that. That's how the dynamic contour works. Okay, if you don't want to use a dynamic contour, I have another way to cut this area. So I will draw the stock here. For example, I will use the 2D high speed dynamic mill to cut this area. Okay. We have many ways to do the cut. Okay, I select the machine region, and I will select an avoidance region. For example, this. And with from outside option, and with the sand tool, I got the same result. Almost the same. Yes, you can see that. This is a dynamic contour, and this is a dynamic rest. Oh, sorry, no rest mill. I will turn off the rest option here. Just normal dynamic mill. I got the same result. So you can see here. Right. Yes, with the dynamic contour toolpath, you only need to select the machine region. That's the hour contour. But if you want to make it with dynamic mill toolpath, you need to select the machine region. You can see here I need to draw another rectangle to define the machine region, and I also select an avoidance region. So We got the same toolpath. Okay, that's all for today. I have show you three kind of dynamic mill toolpath. A dynamic mill from outside, dynamic mill from inside, the dynamic rest mill, and one more is the dynamic contour. So we take a overview. Yes, this is dynamic from outside, the dynamic from inside here, and next we got a dynamic rest mill to remove the rest material as the corners. Yes, that's the rest mill. And we got the dynamic contour. Yes, this is the dynamic contour. Oh, okay. I hope after this video you have some skill on how to use the 2D high-speed toolpath. Uh, the last video on this series, I will show you the remain toolpath, the area mill, the pier mill, and the plane mill. See you in the next video, and good night. Goodbye for now.